Good morning, students. Today we discuss the next topic, that is chemical effects of electric current. What are the different types of chemical effects of electric current? But before we start, today we will come to know that what are the different effects of electric current first of all. What are the different effects? So before we start today, let us go to the recapitulation of the previous class. Okay. So in the previous class, we did, if I go back, the previous class we did about testing of liquids. In the previous class we discussed the testing of liquids. Some liquids are good conductors, some liquids are bad conductors. We discussed about the testing the electrical conductivity of liquids. What are different kinds of liquids? What are insulators? These are the things that we discussed in the last class. First of all, we discussed how to use a circuit tester. And what is a circuit tester? So this we discussed in the last class. Conductors means substances which allow electricity to pass through. Insulators, substances which do not allow electric current to pass through. These are called different kinds of substances which allow the current to pass through. If it allows, it is conductor. If it does not allow, it is insulator. Then we discuss about what is a circuit tester. How to test whether the material is a good electrical conductor or not. For that we have a explanation of here a key, battery, and then the way it is being circulated. So suppose if the bulb which is connected to it, if it glows, then it is a good conductor. So you can see the circuit tester here. Once again I repeat, you have to place the medium in the middle, then you have to place the battery, connecting wires. If the bulb lights up, it means the material allows electric current to flow, and the brighter the bulb, the better is the conductor of electricity. And if the bulb glows dimly, then the passing of current is weak. So even if the current is weak, we can use LED bulbs. LED bulbs are light emitting diode. So these bulbs can be used if the current passing through the circuit is weak. If the current passing through the circuit is weak, then it is called, we can use LED. And if the bulb is glowing very brightly, which means more number of electrons are flowing, as a result the flow of current is very good. Good and bad conductors, substances which allow electric current to pass through them easily are called good conductors, such as silver, gold, platinum, and which do not allow are called bad conductors. But nowadays there are many substances which allow the current to pass through very slowly, feebly. Those are called poor conductors of electricity. We don't write bad conductors, those are called simply poor conductors of electricity. That is the basic part. Then last class we have discussed about these are the electrical conductors we have discussed: copper, then silver, then aluminium, then graphite. These are the things we discussed in the last class. What are the different conductors of electricity? For example, salt water. If you add salt to it, it is conducting. Then these are insulators. So plastic, wood, rubber. These are all kinds of insulators. So liquids which contain, this very important paragraph, liquids which contain salt, they only contain electricity. So the liquids which do not have any salt, they do not contain electricity. For example, tap water. Tap water has some kind of minerals and salt dissolved in it. So tap water will be a good conductor of electricity. But distilled water is free from all salts and is free from all minerals. So distilled water cannot be a good conductor of electricity. Okay. And as I told you, if the current passes through, if the bulb glows, it is a good conductor. If the current passing through is very weak and the magnetic needle shows very less deflection, then what will happen? The current is very weak. So current is low, and that is a function of LED. So we can see we have different effects of current. The effect of current in a bulb is not the same in the compass, magnetic needle. The effect of magnetic needle is not the same in any other liquid. So these are the different types of effects that we will study today. Then how to test the electrical conductivity of liquids? You can place the two aluminum plates, and you can place the liquid also. If the bulb lights up, and it is allowing the current to pass, and that liquid is called a good conductor of electricity. So suppose, students, you take a battery, you take connecting wires, you take two rods and dip the rods in a solution. If the bulb is glowing, which means electrons are passing through the rods from the solution, through the solution. So bulb is glowing, which means the electricity is being able to ply through. The ions are applied. As a result, the bulb glows. So suppose if I take two if I take like this, if I take two rods and if I dip it, suppose I am taking this mouse, so these are two rods I am dipped it, and I have connected wires here, and these two things are in the solution. So if current is flowing, then from this to this the current will flow through the solution, and as a result the current will pass through. So salts dissolved in water are responsible for the conduction of electricity. Again I am telling, tap water, acid solution, basic solution are good conductors, whereas distilled water is a poor conductor. And if you want to make a liquid conducting, which means you have to add some kind of salt or acid or base to it to make the solution conducting so that current is passed through. So some liquids I have already told you. So today we will discuss the chemical effects of electric current. See nicely this PPT. What are the different chemical effects? When electric current is passed through, some effects are shown. Otherwise, how will you come to know that the current is passing through? How will you come to know that the current is passing through? Because there are some effects. That can be chemical effect, that can be magnetic effect, that can be heating effect. Suppose if current is passed through a battery and then the bulb is glowing. How the bulb is glowing? The bulb is glowing because the filament is getting heated, which means this is a heating effect of electric current, which means electric current is passed through the circuit which heats up the filament so that the bulb glows. That is a heating effect of electric current. Then again a current is passed through and it shows deflection in the magnetic compass. If the current passes through and it shows deflection in the magnetic compass, which means it is a magnetic effect of electric current. Did you get my point? So there are various effects of electric current: heating, magnetic, chemical. Now if I give you some effects, how it is happening, how will you identify? So example you see here. When electric current is passed through water, water dissociates into hydrogen and oxygen. Hydrogen is deposited in the negative pole and oxygen is deposited of the positive pole. So deposition of hydrogen and oxygen at different poles is visible in the form of bubbles. Notice point. When current is passed through water, it breaks into hydrogen and oxygen. Hydrogen goes to the positive pole. Sorry, negative pole. Negative pole means the pole which is connected to the negative terminal of the battery. This is a diagram. So if it is connected to the positive terminal, it is anode. If it is connected to the negative terminal, it is cathode. So this is the setup for the electrolysis. Electrolysis means when you pass current through water. I am coming to it. So power supply. Have you seen power supply? Plus is connected to the anode and minus is connected to the cathode. So these are the two poles. And when you pass current through it, the water breaks into water and oxygen. So hydrogen and oxygen. So when hydrogen is deposited over the negative pole and oxygen is deposited over positive pole, you can see the effect in the form of bubbles. So bubbles is the chemical effect of electric current which can be seen when current is passed through water. Then when electric current is passed through the solution of metal, then the different poles get charged. As a result, there is also a chemical effect of electric current. Sometimes the color of the solution also changes when electric current passes through it. Suppose when electric current is passed through it, the color change is observed. That color change is also a chemical effect. For example, potato. There is an example of potato in your book. They have dipped the ends of the rod in the potato and current is passed. A greenish blue spot is deposited on the potato in the positive terminal, towards the positive terminal. So you will see when the greenish blue spot is deposited, which means this is one of the chemical effects of electric current. So the above examples are some of the chemical effects of electric current, and the chemical reaction depends upon the type. So chemical effect can be seen in the form of bubbles.